We shall begin this module by understanding that some firms produce more than one output. The outputs could be closely linked to each other. For instance, in the case of a poultry farm, it produces both chicken and eggs. The outputs could be physically unrelated sometimes. In the case of the production of output, some byproducts could also come. Therefore, we could have byproducts, we could have related products or unrelated products when we speak of multi-product firms.
After studying this module, you shall be able to know about economies of scope, learn about learning curve, identify the difference between fall in cost due to increasing returns to scale and due to learning curve, and evaluate the economies and diseconomies of scope. We shall commence this module by understanding the concept of economies of scope. The firm is likely to enjoy production or cost advantages when it produces two or more outputs. Such economies or savings that arise on account of a single firm producing two or more outputs are known as economies of scope. Thus, if a firm's joint output is greater than the output that could be achieved by two different firms when each produces a single product, then its production process enjoys economies of scale. These advantages occur on account of joint use of inputs, processes, and economies of management, technology, marketing, and so on. The best example is of automobile companies who produce more than one product. Another example of economies of scope is home healthcare, banking, publishing, telecommunications, electronic-based B2B providers, distribution. Automobile manufacturers use the same practices, processes, tools, and materials to design and prototype multiple products. Economies of scope are the main means of systematic reuse in commercial construction. Economies of scope occur when the total cost of producing two types of outputs together is less than the total cost of producing each type of output separately. The cost of producing Q1 and Q2 is less together than separately. The formula is as follows: C Q1 0 plus C 0 Q2 is greater than C Q1 Q2. Let us now understand how to exploit economies of scope. A good way to exploit economies of scope is to expand product range and take advantage of the value of existing brands. Because all factor inputs are variable in the long run, the scope of production can change. The nature of economies of scope can change the structure of industry competition and the profitability of supplying to consumers over time. Economies of scope tends to be sometimes a potential barrier to entry. Economies of scope tend to encourage large firms because efficient production requires multi-product production. Because of this, larger firms potentially have greater access to capital markets, making it more difficult for smaller firms to obtain funds. This higher cost of capital could be a possible barrier to entry. In the most extreme cases, economies of scope could result in monopoly power. Bay 283. On the other hand, there could be potential competitive advantage. Economies of scope can actually help companies gain a competitive advantage. Economies of scope can help to lower expenses on a per unit basis and enhance profitability. Economies of scope can also force companies who are not cost efficient out of the industry. Let us now study the reasons for economies of scope. 1. Joint use of production facilities or other inputs. Many companies share facilities or rent out their facilities or machines in order to save costs. An example of this would be a manufacturer who rents out the machines on the weekend when they are not operating. 2. Joint marketing or administration. An example of this would be for a company to advertise all of their products, creating brand awareness and brand image rather than each product individually. 3. Production of one good provides the other as a byproduct. An example would be the production of bread, which could then be used to also make sandwiches. Let us discuss how to achieve economies of scope. Flexible manufacturing. A company's ability to quickly and effectively switch manufacturing processes to produce new products can lead to economies of scope. The cost of switching is low and multiple products can be produced using the same resources. Diversification. A company's operational expertise and specialization can be applied to other products within the organization. For instance, Procter and Gamble is able to produce a wide range of products because they can afford to hire designers and marketers who can use their skill across product lines. Spreading out the cost to many products lowers the cost of production for each one. Mergers. Sharing of research and development expenses helps drive down costs and allow diverse portfolios of knowledge and products to be established. Supply chains. Linking the supply chains and allowing crossover communication between wholesalers, distributors, etc., raises the ability to eliminate costs. It is less expensive to have businesses operate their supply chains under the same umbrella rather than to have to operate independently. Let us describe the product transformation curve, which shows the various combinations of the two different outputs that can be produced with a fixed amount of inputs. In the figure, we have shown that an automobile company which produces both cars and buses. The curve has a negative slope because in order to get more of one product, it needs to give up the production of the other product. The curve is concave in shape, explaining the economies of scope in production. The concave shape explains the advantages of joint sharing of resources, management, expertise, which leads to cost advantages. If the production transformation curve is a straight line, then joint production would give no advantage. In such a case, an individual company producing only cars and other only buses would produce the same level of output as a single company producing both the products. Let us look into the concept of economies of scope versus economies of size. Economies of scope are different from economies of size. Economies of size involve the spreading of fixed cost over a large number of units of production of the same product or enterprise. Economies of scope involve spreading the cost of a set of resources or skills over two or more products or enterprises. However, economies of size and economies of scope are not mutually exclusive. While economies of scope allow costs to be spread over several enterprises, the size of each enterprise can be increased to also achieve economies of size. Let us now understand diseconomies of scope. When a firm's joint output is less than that which could be produced by two separate firms, then its production process involves diseconomies of scope. This possibility occurs if the production of one product somehow conflicts with the production of the other. Relationship between economies of scale and economies of scope. A firm can reap economies of scope even when its production process is undergoing diseconomies of scale. There exists no direct relationship between economies of scale and economies of scope. Suppose manufacturing guitars and violins jointly is cheaper than producing both separately. This would mean economies of scope. But the production process involves highly skilled labor and is most economical if undertaken on a small scale. This explains a situation of diseconomies of scale. Similarly, a joint product firm can have economies of scale but not enjoy economies of scope. Let us consider a large business conglomerate which has several firms. If these firms produce efficiently on a large scale, then they enjoy economies of scale. But since they are administered separately, they are not able to enjoy economies of scope. Relationship between economies of scale and economies of scope. First cousins to economies of scale are economies of scope, factors that make it cheaper to produce a range of products together than to produce each one of them on their own. Such economies can come from businesses sharing centralized functions such as finance or marketing, or they can come from interrelationships elsewhere in the business process, such as cross-selling one product alongside another, or using the outputs of one business as the inputs of another. Just as the theory of economies of scale has been the underpinning for all sorts of corporate behavior, from mass production to mergers and acquisitions. So, the idea of economies of scope has been the underpinning for other sorts of corporate behavior, particularly diversification. Next, you shall know about the degrees of economies of scope. The degrees of economies of scope, SC, are measured by the percentage of cost savings resulting when two or more products are produced jointly rather than individually. CQ1 represents the cost of producing output Q1. CQ2 represents the cost of producing output Q2, and CQ1 Q2 represents the joint cost of producing both outputs. The degrees of economies of scope can be represented as SC equals to CQ1 plus CQ2 minus CQ1 Q2 divided by CQ1 Q2. When the physical units of output can be added, as in the car-bus example, we can also write CQ1 plus Q2. Due to economies of scope, the joint cost is less than the sum of individual costs. Therefore, SC will be greater than 0. When there is diseconomies of scope, SC will be negative. Thus, the larger the value of SC, the greater the economies of scope. Let us now understand the learning curve. In the analysis of cost theory, we find that a large firm is likely to have lower long-run average cost than a small firm on account of increasing returns to scale in production. This may lead us to conclude that firms which have lower average cost over time are growing firms with increasing returns to scale. However, it would be wrong to generalize that lower average cost are on account of increasing returns to scale. Empirical findings reveal that in some firms, the long-run average cost declines over time because workers, managers, entrepreneurs easily absorb the latest technological information and thus become more experienced. According to Pindyke and Rubenfeld, as management and workers gain experience with production, the firm's marginal and average cost of producing a given level of output falls due to 1. Workers become more experienced and adept and subsequently take less time to complete the same task. And next, managers also learn to handle the production process efficiently, from the flow of raw materials to the organization of the manufacturing itself. Engineers and technicians are able to cut costs by designing better products. Also, specialized and sophisticated tools and plant organization helps in the lowering of costs. Suppliers of inputs may learn to procure and process materials and resources more efficiently and pass on the benefit to the producers. The learning process happens over a long period of time. The firm learns to produce at lower cost as cumulative output increases. Thus, the learning curve describes the relationship between a firm's cumulative output and the amount of inputs required to produce each unit of output. The x-axis measures the cumulative output of x. The y-axis shows the number of hours of labor needed to produce 1 unit of x. The figure shows a learning curve for the production of commodity x. The labor input per unit of output directly affects the production cost because the fewer the units of labor required per unit of output, the lower the marginal and average cost of production. Let us discuss the basic feature of the learning curve. The learning curve is based on the relationship L is equal to A plus B into n raised to the power minus beta, where n is the cumulative units of output produced, L is the labor input per unit of output, A, B, and beta are constants, with A and B positive and beta between 0 and 1. When n is equal to 1, L is equal to A plus B, so that A plus B measures the labor input required to produce the first unit of output. When beta is equal to 0, labor input per unit of output remains the same as the cumulative level of output increases. Therefore, there is no learning. When beta is positive and n gets larger and larger, L becomes arbitrarily close to AA, therefore represents the minimum labor input per unit of output after all learning has been achieved. The larger the beta is, the more significant is the learning effect. With experience, the firm's degree of learning is higher, and this would substantially reduce production costs. In case the production process is relatively new, relatively high costs at low levels, and relatively low cost at higher levels of output would indicate learning effects, not economies of scale. With learning, the cost of production for an experienced firm is generally less, regardless of the scale of the firm's operation. Let us understand it through a graph. In this graph, we are taking output on x-axis and the cost per unit of output on y-axis. AC1 is the average cost curve of the firm. The firm moves from A1 to A2 along AC1. This enables the firm to lower costs. The movement from A1 to A2 is due to increasing returns to scale. However, when the firm moves from AC1 to A3 on AC2, there is reduction in cost on account of learning. Hence, the figure shows that a firm's average cost of production declines over time and there are economies of scale in production. Let us now understand the significance of learning curve. The learning curve plays an important role in the production plans of firms. In the present times, where competition plays a dominant role, enterprises are always in the constant process of discovering methods to produce low cost and efficient products. The firms keep on launching new and better products time and again. As a result, the estimation of the cost of production of new products is done, and learning curve enables the firm to produce and proceed more efficiently. According to Pindyck and Rubenfeld, because there is a learning curve, the per unit labor requirement falls with increased production. As a result, the total labor requirement for producing more and more output increases in smaller and smaller increments. Therefore, a firm looking only at the high initial labor requirement.
In this module, we have learnt about the following. Sometimes firms produce more than one output. The outputs could be closely related to each other, the products could be closely related to each other, as in the case of a poultry farm which produces both chicken and egg. The outputs could be physically unrelated in some cases, where the production of one product actually yields some kind of byproduct which could be valuable for the firm. Typically, this can be seen in the case of petroleum extraction. There is a wide range of products, including even cosmetics, which come out of as a byproduct in the case of extraction and refinement of petroleum in the petroleum refineries. The firm is likely to enjoy production or cost advantages when it produces two or more products or outputs. Such economies or savings arise on account of a single firm producing more than two outputs, and this is known as economies of scope, unlike the other type of economies which is known as economies of scale. The firm's joint output is greater than the output that could have been achieved when two different firms produce the same product singly. At such a time, those firms would be experiencing economies of scales. They may be experiencing economies of scale, whereas in the earlier case, when there is a multi-product firm, then it is economies of scope. The advantages that occur on account of the joint use of inputs, the processes, the economies of management, of technology and marketing and so on, all lead to such economies of scope. The best example is about automobile companies who very often produce more than one product. They have a product line which distinguishes between different types of products, and sometimes they may also have some byproducts. The situation of a joint production of two commodities can be depicted through a production transformation curve. Such a curve shows the various combinations of two outputs or two products, two commodities that can be produced with a fixed amount of resources or inputs. The curve has a negative slope because in order to get more of one product, it needs to give up the production of the other product because of the limitation of resources. The curve is concave in shape, explaining the economies of scope in production. When a firm's joint output is less than that which could be produced by two separate firms, then its production process involves diseconomies of scope. The possibility occurs if the production of one product somehow conflicted with the production of the other, although this may happen rarely. A firm can reap economies of scope even when its production process is undergoing diseconomies of scale. There exists no direct relationship between economies of scale and economies of scope. The degrees of economies of scope are measured by the percentage of cost savings resulting when two or more products are produced jointly rather than individually. The analysis of cost theory, we find that a large number of firms are likely to have lower long run average cost curves than the small firms on account of increasing returns to scale in production. This may lead us to conclude that firms which have lower average cost over time are growing firms with increasing returns to scale. However, it would be wrong to generalize that the lower average cost are on account of increasing returns to scale. Empirical findings reveal that some of the firms in the long run average cost in which the long run average cost declines over time is because workers, managers, entrepreneurs are easily absorbing the latest technological information and they become more experienced, and this is known as learning by doing. The learning process happens over a long period of time. Firms learn to produce at a lower cost as cumulative output increases. Thus, the learning curve describes the relationship between firms' cumulative output and the amounts of input required to produce each unit of output. The learning curve plays an important role in the production plans of the firm. In present times, where competition plays a dominant role, enterprises are always in the constant process of discovering methods to produce low cost and efficient products. The firms keep on launching new and better products time and again. As the result of this whole process, the estimation of the cost of production of new products is done, and the learning curve enables the firms to produce more efficiently and produce more.